And we're back. I left you with a day for the line graph ideas to marinate. And hopefully they have marinated well and you're now ready to actually go and do something. But as always, I do like to repeat a couple of times because repetition helps with these things. So one more time, in line graph, an agent workflow, a particular pattern for how you will run an agentic system is represented as a graph, like a tree structure. You use state to represent the current snapshot of affairs, the state of the world at any one point. And you build nodes and edges, which are Python functions. And a node decides how to go from one state to another. And edges and nodes do the work. They actually carry out something which has consequences. And edges decide what to do next once a node has run. And you remember, I talked about 5 steps, and I tried to make it clear that the thing that's a bit of a head twister is that these 5 steps that I'm talking about, they all happen when you run your code, and they happen before you can even run your agents. So when you run your code, there is this pre-thing that has 5 steps in it, and then the agent running. And that pre-thing is what would be called graph building. That is laying out what you want to do, and then you kick it off to actually do it. And those 5 steps, of course, you define your state class, describing the information that will be maintained. You start the graph builder. You then create a node, or many. You create edges to hook it all up, or many. And then you compile the graph, and you're now ready for prime time. All right, so I want to get a little bit deeper about the state before we get to the code. The final thing before the code. So state is what's known as immutable. It's a word that people like to say a lot, and hopefully you know what it means, but you might not. So let me be very clear. What it means to be immutable is that you will never change the contents of this object. It is something which, once you've created it and assigned the values to it, it keeps those values, and you don't ever do what's called mutating it, which is changing it. And that's important because state is something which is going to represent a snapshot of the system. You want to be able to always go back to that snapshot. It's something which in itself, if the contents of that state changes, you wouldn't be able to maintain that snapshot. So just to get concrete on what that means is that when you write the function for a node, that function is going to be a function which quite simply receives a state as its input, and it returns a state as its output. And the thing that it returns is different, a different object, a different instance of state than the one that came in. So in this example called my counting node, let's imagine that we have a state object, and the only thing that it has is a field called count. And count is something which is a number that counts. And the purpose of my counting node is to add 1 to count. So I realize this is quite artificial, but just to give you a clear sense of it. So this is a function, my counting node. It takes a state, old state. It collects the count that is stored within old state.count. It adds 1 to it. And then it doesn't return like the old state object. It doesn't try and set count in old state. No, it creates a new state object, and it sets the new state's count to be this incremented count. And it returns that new state object. And I realize I'm belaboring the point, as I often do, but it's an important one, and you need to keep this in mind, and otherwise you'll get in all sorts of traps. So there's one more complication. For each of the fields in your state, you can optionally specify a special function to be associated with that field. And you're specifying this to LangGraph. You're saying to LangGraph, hey, I want you to know that for this field in my state, it's a special field that has a reducer, this function called a reducer. Reducer is the sort of technical name for this kind of function. And the job of the reducer function is that when you ever return a new state, I was going to say update the state, but that might be confusing. Whenever you return a new state, which is a new version based on an old state, you've done something, you've returned a new state. LangGraph can use this reducer function to decide how to combine the specified field in your new state with the current state. You see that? So it can use this function called a reducer so that if you have a field, maybe it's count, maybe it's a different field, it would use that to combine it with the old state. Now that I've said that, you're probably thinking about that for a second and you're like, hang on, why? Why would you need to do that? We've got a node like this. We've got the old state. We can do that ourselves. We can just simply update the field in whatever way we want. Why do we need to specify a reducer function separately? Well, here's why. Because this means that LangGraph can run multiple nodes at the same time. They can all be running and they're all returning state, and there's no risk that one node runs and it overwrites the progress that a different node made at the same time. For any field that has a reducer like this, it will always be able to work. They'll be able to combine different states behind the scenes. And that's the clever trick that allows that to be so. So you'll see if this is seeming a little bit abstract, it's going to be concrete when we look at the code. We will indeed use a reducer, and it's going to be super clear why we need to do that and how it helps. And a warm welcome back to Cursor. And also we are coming now into week 4, LangGraph, and into lab 1. And it's not only welcome back to Cursor, it's also welcome back to notebooks. You know, I love these things. I know the mixed popularity with others, but hopefully you'll put up with them for a bit. We'll use code as well this week too, don't worry. So we're going to start by doing some imports as we get started. And then we also have some constants. Ignore these for now. We'll use them in a bit. They're silly. And we're also going to have our favorite little thing here, load.env. You may be wondering why we didn't have that during Crew week. It was absent. And the reason is that Crew just does that for you automatically. Crew uses the .env file itself, and so you don't need to run it. Okay, now I need to explain something called annotated. So hopefully you're somewhat familiar with things called type hints in Python, an optional feature that is often used in engineering. To give you an example, supposing that we have a Python function called shout that takes some text. The job of shout is to print the text in uppercase. That seems fairly simple. And let's just shout hello like that. Hopefully no surprise. Hello in capitals comes up. Well, the type hints is when you are clear to Python what is the type of variable that you're using at each point. So you can say that that text is a string by putting :str, and you can put here that will return a string, or it's not returning anything, it's returning none. But if we also have it, if we leave it like this, if we have it be returning a string, then it will be unhappy, but we would need to then also return text.upper as well. And then it will run. So these are called type hints, and they are a useful way of specifying what's going on. There is a feature that you can use called annotated, in which we could type annotated string, comma, and then we can put some message here. Something to be shouted. And this is something, I need to close the square brackets. This is just extra information that's a sort of FYI that's included in here. Python doesn't make any use of this at all. But if we are going to provide this function to another platform or in some other context, someone might want to read how we've annotated it, and that might be useful for someone. So annotations can be used for this purpose of kind of tagging variables to have a purpose. So this should run without any change at all. That is completely ignored. And it's just a useful way of adding some extra information in case it matters to somebody else. And it is going to matter to somebody else. LangGraph is going to want us to annotate in order to tell it something. Let's come on to that. So I explain here again, you could have a variable like my favorite things that could be a list. And you could say that my favorite things, you could actually not just describe it as a list, but say that it is annotated, it's a list, and these are a foo of mine added as an annotation to my favorite things. So why do I tell you this? Well, it all comes back to these things called reducers. We are about to define our state object. And when we do so, we're going to give it a few fields. And when we define those fields, we have to give them a type. And when we give them a type, we don't just specify the type, but we use annotated to be able to specify a reducer if LangGraph is expected to use a reducer. That is the technique. You use annotated to do that. And that is what we're going to do. And as it happens, LangGraph comes with one out of the box that's very useful for us called add messages. And that is one that I just imported up here. So if you look up here, one of my imports was from langgraph.graph.message import add messages. So that is, it's like a function, and it's a function that you can annotate with if you want to say, hey, this is the reducer I'd like you to use. So to make this feel real, let's go ahead and define our state. So you remember step one in the puzzle is to define the state object. That is what we're doing here. We are going to have a state object. Now, state objects, you can define them in many ways. They can, in fact, be any Python object that you want. It's most common to either have it be a pydantic object that we met in the last week. It can be, or we met it the last 2 weeks. It can be a pydantic object, meaning it's a subclass of base model. It can also be something called a typed dict, which is a particular type of dictionary in Python where you specify what the keys need to be. But it can also be anything. But it is quite common to use either pydantic objects or typed dicts, and we will use pydantic since that's something that we're familiar with. So we are going to have a state object defining the state of our system, and it only has one field, and that's called messages. And that is going to store in it a list of messages. And this list of messages is going to be passed around our graph, and over time it's going to build up as messages get added to it. And so we are going to say that it's something that's annotated. It is a list. So it consists of a list of things, of messages. And we are going to then, because we're annotating it, we can provide an annotation that's ignored by Python, but it can be used by LangGraph. And that annotation is where we get to specify the reducer, the function that will be called in order to combine one state with another. And we're going to use one out of the box called add messages. It is a reducer that is used to add messages. And it's very simple. It's very vanilla. All it does is it assumes this is a list. And if you return something with an items in the list, it just combines it with everything else in the list before. It concatenates these lists together. That's all it does. So hopefully that makes a bit of sense. If not, then you'll see, it'll become clear as we use this exactly what's going on and why with the use of this and the reducer and how it's working. So step one, we define the state object. Step two, we start the graph builder. And that is just a matter of calling this thing called state graph, instantiating a state graph, passing in state. And one thing to get your head around here is that what I'm passing in there, the thing I've just highlighted, it's not an object. I'm not instantiating. I'm not creating a state and passing that in with messages and so on. No, I'm passing in the class. I'm passing in the type of thing that represents our state. That is what I'm using to create my state graph. And this is beginning the graph building process. This is part of the 5 steps before we actually run our agentic framework. Okay, so here we are looking at our node creation. Remember, a node is a function. So we're going to create a function. It's called our first node. It takes an old state and it returns a new state. Its states are immutable, as we say, and so we are not going to do anything. We're not going to come and mutate old state. In fact, you may see from the way that it's grayed out here that we don't actually touch old state, which is unusual, but just for this example. So what are we actually going to do? So we're going to make a string called reply, and that reply is going to be some random word choice of a noun, and then the word are, and then a random choice of an adjective. And we're going to create one of these kinds of message structures, an OpenAI familiar message structure, and put that into messages. We're going to say that the new state is a new state class. We're going to instantiate it, passing in this messages, and we are going to return that, the new state, and that is the end of our first node. And we then call graphbuilder.addNode. This is how we officially add it to the graph that is being built. We give it a name, we call it first node, and we pass in the function that represents the node called our first node. Okay, so we're going to run that cell, and now we're coming on to look at creating our edges. So you can see here that I now call graphbuilder.addEdge to add a couple of edges, and you'll see that there are these words start and end there. So what are they? Well, these are things that we've imported at the top from langgraph.graph. They are constants, start and end, and of course they signify the beginning of our workflow and the end of it. And so Here, what we say is we want an edge to take us from the start to our first node. And then we want another edge to go from the first node to the end. Okay, that sounds logical, doesn't it? So we'll run that. And now with that, we get to step 5, which you'll remember is compiling the graph. It's saying we're done. This is our workflow. And we can now display it. This is rather nice. A quick way to show visually what it is we're talking about. And hopefully this will be no surprise. We've got a start going into our first node, going into our end. What could be easier? That's lovely. Okay, so we've done the 5 steps, which is, of course, the first part of running a land graph system. We've compiled our graph, and we've done it by adding nodes and edges. It's now time to run it. Okay, and what we're going to do is, to run it, we're going to create a Gradio chat function. Why not? Remember, Gradio chat functions take the user's current input and the history of prior inputs, and it's meant to respond with the next output. That's just what you do with a Gradio chat function that we're going to pass into Gradio's chat interface right there. So that's what we have to do. So what do we want to do? Well, we're going to turn the message into a standard OpenAI format and put that into a message. We're then going to create a state object with that as the message. We are then going to invoke our graph. And this is the key LangChain word, invoke. You may be familiar. Sorry, I said LangChain. It's the LangGraph word, invoke, but you may be familiar with it because it's the word in LangChain as well. So you invoke a graph in LangGraph with the state in order to get the result. And so it's going to execute our graph. And what will come out will be the result. And we will print it. And we will also return it. And that will come out of our chat function. And so with that, let's run this and see what happens. Well, we have a Gradio UI. That's good. Let's say hi there. Muffins are haunted. Is that so? Penguins are sparkly. You don't say. Penguins are outrageous. For real? Pickles are untrustworthy. You get the idea. So this is the result of our small language model that is picking a random noun and adjective. And I show you this if you're wondering, what on earth are you doing? I'm doing it to show that the LangGraph setup has nothing to do with LLMs necessarily. The node is just a function, in this case, a silly function, but it's a function there, and it's taking in a state and it's returning a state, and it doesn't need to have anything to do with LLMs. Now, down here, I'm printing the result of this. And let me just show you that print statement. We're printing what's coming back from calling invoke on the graph. And I want to point out that it may be something a bit different to what you're expecting, because it's not messages with just a list of strings. It's got a list of these things called human message, which you may know from LangChain work. It's like it's a construct to package things up. And this is, of course, the result of the reducer running. And when I said before that the reducer simply concatenates things into a list, I wasn't telling the full story, because it also does some of this packaging up that comes with LangGraph. So if it just takes the text that's come back, it knows how to package it into a human message in terms of the things that I was saying, and an AI message in terms of muffins are haunted and penguins are sparkly and the like. So this is some of the stuff happening behind the scenes as a result of LangGraph, which doesn't really matter to us. We're taking advantage of that, but we just wrote a super simple state, super simple node. We made a state that contained messages. We made a node. We take in an old state. We return a new state, which is using this random sentence, and it works. We can invoke our graph and get a response, and we can have a conversation, a rather one-sided conversation with a silly language model. All right, let's do something more sensible. Okay, now it's on to a proper example that we'll use with LangGraph. To state the obvious, the reason I showed you the silly example was because I wanted to show that nodes don't need to have calls to LLMs, and they still do what they're meant to do. But now we are going to add an LLM. So we start by defining the state. We create a graph builder with that state. And now we create a LLM, a real LLM using Chat OpenAI. So Chat OpenAI is a construct from LangChain, the sibling to LangGraph. And that's what we'll be using to connect with our LLM. And now you don't need to use LangChain's LLMs for this. You can use any LLMs. You could directly call the LLM yourself. You could also use maybe OpenAI Agents SDK. But it does make things a bit simpler sometimes if you use LangChain, and most of the community examples, of course, go from LangGraph to LangChain. So it's easy to do it that way, and that's what we'll do for here. So we're going to create a new node called chatbot node. It takes an old state and it returns a new state. And what does it do? Well, it takes the LLM and it invokes on that LLM. So it's the LangChain LangGraph word invoke, passing in the messages from old state. So old state has a messages field, and that is what we pass in. And then for the new state, it creates a new state object, which contains within it, as in its messages field, it contains the response. And we return the new state. And we add that node called chatbot into our graph builder. Done. Now we'll add some edges from start to chatbot, from chatbot to end. Done. And now we will compile our graph, step 5, and we'll look at the graph, and sure enough, it goes start to chatbot to end. And then we put it all together in a simple Gradio chat function. It takes an initial state, which is a state object set up with these messages like so. We then call graph.invoke to actually call our graph. We print the result, and we will also show the result back in Gradio. So here it is, and I can say hi there. And it's actually calling OpenAI now. It's not using our silly adjectives. And you'll see down here that there's the user message and the response coming in these objects, this human message object that is coming back. Sorry, that human message is my hi there. I mean, there should be an AI message. There it is. There is the AI message, which is the response actually coming from OpenAI. But one thing that's worth noting is that if I continue this conversation, every time we are invoking this graph, you will see what you have probably already suspected, which is that we're not actually keeping track of any history here. Let's see that in action. If I say, my name's Ed. Nice to meet you, Ed. How can I assist you today? What's my name? I'm sorry, but I don't have access to your personal data. So there's a sign that it's not able to keep context, and you can see it yourself if you read the information that's going to and fro. So because we've just got this simple graph that we were invoking each time, there's nothing particularly interesting happening here, and the state is just contains that doesn't contain the history or anything. So that's one of the things that we clearly need to address. And the good news is that we will indeed address it, but the bad news is not until tomorrow. But we'll also address things like tools, our old favorite, along with a couple of other things. So look forward to it. I'll see you then.